So you can also have horizontal asymptotes. So let's say you have a graph like this, and there's a horizontal asymptote like that. Well, you could have your graph maybe comes along like this. And you say, as x approaches infinity, oh, say this is at b. And by the way, it's a horizontal asymptote, so y equals b, like a horizontal line. Sorry, I left it out. So say you have a horizontal asymptote at b, not negative b, but like this is b. That looks funny there. Okay. Anyway, it's the equation of the horizontal asymptote is y equals b. Okay, so as x approaches infinity, as it's going this way, then f of x is approaching b. And you could also have, a horizontal asymptote at b, and maybe it's coming up this way. And so as x approaches infinity, f of x, well, this is going to look the same. F of x is approaching b. Okay. I feel like I'm leaving something out. Oh, one other thing. You could have a horizontal asymptote. Now, vertical asymptotes, you can't cross a vertical asymptote, but horizontal asymptotes you can. So you could have a function that goes something like this. It goes down, but then eventually it approaches the horizontal asymptote. It almost looks like it's a constant function. So you have something like that, where it's crossing the horizontal asymptote, and that's okay. So we would say as x approaches infinity, f of x is, I'm putting it still at b, f of x is approaching b. Okay? So it kind of doesn't approach b right away, but in the long run, as the numbers are getting larger and larger, it starts to approach b. Okay, so how do we find horizontal asymptotes? Well, it has to do with our definition of a rational function. So remember we had polynomials. Well, polynomials can be written a sub n, x to the nth, plus, and then we have all those terms, remember? And then plus the last term is a constant. Now, I'm just going to put the leading term and the constant term just to make it easier for you. But there's all those terms in the middle, standard form. Okay, but then in the denominator, we have a different polynomial. So maybe it's b sub m x to the mth plus a bunch of terms. And then at the end, you have a constant, or you might have a constant. Okay, so that's what how they're written in standard form, right? Okay, horizontal asymptotes are based on the degrees. So based on n and m, the degrees of the two polynomials. Okay, there are three cases. So case one, if n is less than m, so the degree of the numerator is less than the degree of the denominator. If n is less than m, then your horizontal asymptote is at y equals 0. It's the x-axis. So I'll put that in parentheses. It's the x-axis. So that happens sometimes. The degree of the numerator is less than the degree of the denominator, and you just have a horizontal asymptote at the x-axis. So we saw that with our rational function. Remember, we were approaching 0. And what was that function? That function was 1 over x. So the degree here, n was 0, and the degree here, m was 1. And so you have that horizontal asymptote at the x-axis. Okay, so there you go for that. If the degrees are the same, so if n equals m, then the horizontal asymptote is the coefficients. It's a sub n divided by b sub m. That one's kind of weird, but it's one of my favorites. So if the two degrees are the same, you get this line, this horizontal line at a sub n over b sub m, whatever those leading coefficients are. Okay? And then the case, it says, well, if n is greater than m, then there's no horizontal asymptote. We do have another situation, but we'll talk about that later. Okay, so find the horizontal asymptotes, if there is one, of the graph of each rational function. So you're looking at the degrees. What's the degree here? N is 1, M is 2. So that's that case 1, where N is less than M. So then you have to look and say, okay, well, what was that? And it was y equals 0. That's the horizontal asymptote. Okay, so find the horizontal asymptote. We found it. It was the first case. All right. Now, in this case, or in this example, n is 2 and m is 2. So they're the same. So this happens to be case 2. They don't really call them cases in the book, but anyway, y is equal to those leading coefficients, 4 divided by 2. So y equals 2. So you're going to have a horizontal line at 2. It's going to be the horizontal asymptote. By the way, you can have lots of vertical asymptotes. You can only have one horizontal asymptote. So you can have many vertical. You can have many. You don't have to. You don't have to have any, but you can only have at most one horizontal asymptote. Okay. And so now here's this case. What's the degree here? 3 in the numerator, so n is 3. And what's the degree of the denominator? 2. Okay, so 3 over 2, that means there's no, so we're case n is greater than m, so that's case 3. And so there are no horizontal asymptotes. Pretend like that says horizontal. I should have been a doctor with my handwriting. Okay. And that's how you do horizontal asymptotes. So it's a little bit to remember. You might want to make yourself a little chart or put it on your note page, of the 3 different cases.